Hey, hey. Hello, everyone. Hello,
Hello.
Darren. How are you, my friend?
Hey, I'm good, Noseman. How you been, man?
Oh, being great. Yeah, this is my last stream for the year, and I think your last stream for the year, isn't it?
Absolutely. Yeah. Wow. Well, how honored am I that I get to be here with you on your live stream. That's awesome.
You can
And
be
all of our viewers. Hi, everybody.
you can be with me anytime you want, Darren. You know that. You're a friend.
Thank you.
You're
Thank you
very
very
welcome.
much.
So, welcome everyone to the third and final demystifying post-production mechanical rigging and it's the last show I am doing for 2023, and we have a lot of stuff, exciting stuff, prepared for 2024 and the future. So let me go through the quick housekeeping, and let me bring up my screen. I'm going to do this. Let's do. Oh yeah, I hadn't added the stage. Yep, Kyle is in the background helping us with the production. I'm going to do my best to destroy his fine work, but hey, that's how I roll. So let's begin. If you want to know all the events that are going on now, happened in the past, or happening in the future, go to the Maxon events page. And while we're doing this, I'm going to paste the links in the chat. If you want to watch these videos recorded, you go to the Maxon Training Team YouTube channel. They are streamed concurrently on the Maxon YouTube channel and the Maxon Training Team, but the Maxon Training Team YouTube channel hosts the recordings with timestamps kindly provided by the all-wise Dr. Sassy, and he always makes sure he checks our work and tells us what we got right and what we got wrong. And it's amazing to be part of a team like that, where you get constant feedback from everyone, mostly positive, but always in a good direction. I have learned a lot, by the way. So let's move on with the new renamed Maxon ZBrush YouTube channel. If you want to learn ZBrush and check out the amazing shows um, that we have on the subject, go to youtube.com at Maxon ZBrush. And let me paste this. If I do a mistake with the paste, someone's going to tell me. If you want to become a certified pro user or a certified trainer, go to the Maxon certification page and go to this little drop down here and click on the certification links, and it will give you the certification topics, which not only will guide you towards the certification itself, but it will give you you can use it as a visual guide, as a guide for the kind of information that we think is necessary for someone to learn Cinema 4D properly. So go down this list and check and see what you do or you don't know. Now, as a token of appreciation for you being part of the shows and watching us, oh, let me go to the topics list. Did I do that? Yes, certification. Go to the merch store, ask the trainer. Let me paste this, and using for the next few days, for the rest of December, Maxon rigging, all caps, no spaces. I'm going to paste that in, and you can get your complimentary T-shirt. You only pay for postage and packaging, and of course, make sure you visit Cineversity um, and look at all
Ooh.
the amazing videos we have available for you. And also the oldsuniversity.com that still has tens of thousands of videos on all subjects. And although they may be outdated, most of the information presented in those tutorials is still relevant today. Do yourselves a favor, look past the different interface and check out all of Dr. Sassy's tutorials, which is a university of learning how to do 3D. I have learned a ton, if not most of everything, from his tutorials, and I'm actually proud to admit that and to say that Dr. Sassy is my colleague and my friend. Okay, and I don't do compliments easy, by the way. So today, let me do this. I'm going to bring up my face first. So shall I do it or shall I let Kyle do it? I'm going to let Kyle press the button because I usually press the buttons all wrong. So what we're going to do today, I'm going to explain, is we're going to use all the principles we talked about. There you go, sneak peek. We're going to use the principles we learned over the last 2 weeks. And I know that 2 weeks for this kind of information is very little, but these are just the fundamentals. So we are going to have more content on the subject as we move forwards in the form of quick tips and tutorials and all that. So today I'm going to go through some very specific projects which I used when I was preparing for this, and we're going to set them up from scratch. So this is the final version, for example, and you move this and everything moves. And we're going to start from the very
Wow.
beginning,
That's
and we're going
cool.
to move. Thank you very much. This is something like one of those.
Hmm.
Can we say brands here? Some of those teenagers which don't work, right? Is that no? That don't want to work. Lazy boy, whatever, something like that. I don't know if it's the the same brand, but in any case, how we're going to start working with this is I'm going to go here in my huge tab of stuff, and I'm going to find the. Let me find it. We have quite a few things. The recliner. I'm actually going to open it. I thought I had that all open, but obviously I didn't. So I'm
So
going to
that's
find
that's a recliner setup.
yes. And let me tell you which one. Are you going to see the? There you go. So this is the original file, and the what I've done here is I've already created a bunch of joints. I don't want to. I don't want to waste time figuring out where the various uh, pivot points are. Now, as I said in one of the previous sessions, the idea is that this is all working in 2 dimensions. Although it's essentially 3D, the rig itself doesn't need to be 3D because this only unfolds in 2 dimensions, right? It doesn't pivot around here and all that. Everything happens sideways, up and down. So that's why, in most cases, when you have these kind of assemblies, you don't require any specialized stuff. We did see that odd delta rig setup that goes in 3 dimensions. That wasn't pure IK. But in any case, the reason I started it like this is just to save some time from setting up the joints. And pretty much every potential pivot point, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. This is basically just a stop they have on that model. This is where I put the joints. Now, here we have a bunch of rivets, and you will see these are all the rivets. I don't need them for this, for now at least, so I'm going to just hide them. So we can see the pure setup. And
Hmm.
what is going to be the most important part of today's topic is when we look at a rig, what steps do we need to take in order to analyze it and start rigging it? Because for the uninitiated, which anyone that has watched any of previous shows, you are initiated now, right? You got um, the first idea of what we have here. But for the uninitiated, you need to set some conditions, um, actually transfer some conditions from real life to your rig. For example, this blue thing here is the part that's screwed to the armchair, the recliner, or whatever this mechanism is from. And it won't move. And this is something that we didn't make it up ourselves. It's part of the physical limitations of the contraption we are trying to rig. And understanding these principles is, I think, the basis, what I'd like you to take away from today's lesson. So, knowing that this is immovable, we can easily define that this over here and this over here are two immovable joints. These two are just going to be here and things are going to rotate around them. So, to begin rigging this, it's good to start from the static positions, from the points that don't move. And now we need to select, is it this one or is it this one, the one we're going to start with? And the reason it's important to define how something is going to start is that taking it step by step and creating, first of all, the rig for the green part, then the rigging part for, let's say, the purple and the blue. And then this, you have to take it step by step. You cannot look at this holistically as You will get, and if someone can do that, a university needs to give them 10 PhDs. It's very hard for any human to assess this immediately. It needs breaking down. So, first choice, do we start from this or do we start from this? Well, there are two differences. If I start from here, first of all, what is the first thing that is attached to this? And it's this L, inverted L shape. This whole thing is immovable. It doesn't have a pivot here. This is welded to this. And this leads to two more attached things. This is attached to this, and this is attached to that. Excuse me. So, depending on which one has fewer dependencies, that is going to be the one we're going to use to initiate this. So the only motion that this one does is pivot over here, nothing else. It just goes up and down. This one, on the other hand, although this little bit moves left and right because it pivots here, the second one, and don't forget, we are going to make this using two joints, those little triangles. Two joints, actually it's three joints, but two bones for each. So 1, 2, 3, or let's say 1, 2, 3, or 1, 2, 3, and so forth. We're going to break it up into those little triangles we saw. So what is the problem with the problem with this one is that although this is static, right, this just pivots around this hole. The second part of this joint, if we were going to go 1, 2, and 3, is not user defined. It's defined by the rest of the relationships, where this is, how this moves this, how this moves this, and so forth. And therefore, because the position of this, where this is going to end up, seems to be a bit more complex than where, let's say, this is going to end up, because this only has one relationship. It's tied to this, which is tied to this, and that's it. This can
Can I ask
only...
a question?
Yes, please.
In the top of this, behind the green L
Yes.
component, the
Yes.
orange support bar and the red support bar connected by a yellow support bar, and then there's this yellow dot.
Yeah,
Is that a
this.
pivot point? Is that the
No,
pivot point, or is that
no,
just a
that
hole in the green bar?
exactly. That's just the
Okay,
model. And
thank
I
you.
think this is where they screw the pillow of the seat. So this is screwed to the chair. This and this screw the pillow that goes on top of here, because when this
Okay,
moves,
got it.
yeah, when the recliner moves, and let's go to our side view. But it's actually an interesting question, because I went through all these things. When this opens up in whatever configuration it opens up, the seat raises, so the person is, lying back, and the footrest just extends, so someone puts their feet on it. Right. So these are just screw holes for the seat, and these are screw holes where it's on the recliner itself. But yeah, this is what Darren is saying, which is very important, is always ask yourselves, I mean, this hole, I know it is a stop now because I removed it, but these features are going to inform you on several of the aspects of the motion of each and every one of your mechanical rigs. So let's begin with the first one, right? We're going to start simplifying this now as we move forwards. And what I'm going to do is find this joint here. So it's up here. The second one is this one here. Now, it doesn't matter that this is an L. We're going to go from here to here. That's the second one. And from there to this one. And I just need to zoom in to select it. And this is one down here. So the first three. Now, make sure you name things. So select them all. Go to the basic. Let's name them A joint and a space. And I'm going to name this A joint 1, A joint 2, and A joint 3. Okay? So let's put them here so we can start seeing what's going on. Always add a root on top. So Alt-G and add a root. There we go. And let's do this. Let's add an IK tag here, rigging IK, if you want to do it using the automatic tools, the create IK chain and all that. You can do that, but I like to do it manually. It just clarifies things for me. Add the goal, bring the goal up because it executes before anything else. And this is the motion this is going to do. All right. Now, what I like to do at this point is when I'm showing this as an example, all you have to do is just copy and paste the geometries in each relevant joint. But if you're making this for as a project, it's good to use constraints, parent constraints or other kinds of constraints, because having your joint chains separate than your geometry always allows you to work a bit nicer. Whereas the way I'm going to do it now, just for the sake of speed, is, for example, I'm going to cut this, I'm going to click on this, I'm going to paste it as a child. And the reason I do that is when I set my preferences up, the first thing I do, I change the paste object at child. And this way it allows me to very quickly do things like these. So now look at this. This is moving up and down. Excellent. And by doing this, it's easier to understand what's going on rather than having this thing up here and trying to figure out what is going to move, what is it going to move. So put the things in their place or constrain them as you go. Then this, I'm going to cut it and I'm going to paste it as a child of this. So we have the first two already done. Now, the question is, what's the next step? What do we need to do now? Well, remember when I said we were going to start either with this one or with this one? Well, we're done with this one, right? That's it. So then we go to the next possible one, because these are a bit out of the question for now. Everything here is going to be relative to whatever motion is going to be produced by everything else. So the next one is to start with this. So this is a fixed point. And because it's a fixed point, I'm going to set it as the root of the next joint hierarchy. So that's one. That is two. And zoom in. And that's a third one. There you go. Three more. Select them. Do the exercise. B joint space. And then just double click one, double click two, double click three. Excellent. Make the joint chain. Press H. And always, again, it's advised to use visual aids. For example, middle click and go and change the color to something else. So you can see what's going on. It's easier this way. It allows the brain to process the information a bit better. Go here, Alt-G this into, this is A root, the previous one, and this is B root. And let's do the same thing. Right-click, rigging, IK, third, add goal, put the goal up here. So now we have these two relationships. Now I can take the B joint and do that. I can take the goal, and do that. But here's the great thing. As I'm moving this will move, correct? So what do I need to do? Well, I need to take that B joint that controls that position and just make it a child of the same one we used for this, which is this one over here. So take this and put it, let's see which one it is, A joint. Put this under the A joint. Again, you would do that using a constraint if you're doing it correctly and so forth. Let's see what this produces. And look at that. Now we have the other joint. Let's do the relationships. Cut, click, paste. Cut, click, paste. Watch this. There you go. So now we have these two things moving. And you don't need to know how this is going to move. If you analyze it and move forward a step at a time, the motions are going to reveal themselves, because this was apparently modeled of an actual mechanical system that works, because there's always a chance that if you're just modeling without that into consideration, that your mechanism will seize. So there you go. We have that. Now let's talk about the rest here. And this is the funny part. This point is controlled by that. So I'm going to see this one and this one. So this is the typical scissors rig we did in the first week. And by the way, DPP stands for demystifying post-production. So this one needs to be attached because we don't have anything on the other side. This will be attached here. The blue one here will be attached here. And this is a scissors rig. So a scissors rig is very easy to make. You use 1, 2, and 3. It doesn't matter how you're going to move them. When you see a cross, that's a scissors rig. And it's as simple as that. So let's create a scissors rig. Well, we need to find this joint. So right click here and find this joint. I found the other one. So control right click. There you go. That's my joint. I'm going to make a copy of this one because I want a new joint exactly in the same position. Let me drag it down here. And let's now control right click here. This is another joint. That's the second one. And let's find the third one. Control right click, a joint 3. That's the other one. So let's copy it underneath here. And we have 1, 2, 3 joints. Select them all. Call them C joint space. That's not a space. And set 1, 2, 3. Let's do exactly the same thing we did before. Let's select this, add a root, and this is going to be C joint. Jint. I'm going to leave it as jint. Is it a bad word, jint? No. So let's go here and add an IK tag. Let's put the third one. Let's do that.
So
now,
did you try this with sorry to interrupt. So did you try this with the connectors first? Or you had already done something with connectors and you decided as like an exercise you wanted to do this just with joints?
Are you talking about dynamics connectors?
Yes, sir.
Oh, no. I want it to be fully, let's say, deterministic. That's not the absolutely correct term. I don't want any simulated aspects as part of this. I want this knowing that it's a device that works and that it, the way this is put together with screws and, scissors and crossovers and all that doesn't require dynamics unless you are making something that requires dynamics. Now, having said that, our connectors, although they're extremely good at certain things, they're not 100% stable because they use iterations to calculate the position. So in some cases, there's a bit of instability. They work great for various things like pendulums and stuff like that. Maybe car wheels, because if it wiggles a bit, it doesn't really matter. But for these kind of things where you want them absolutely solid, absolutely perfect, this is the best way to go in my view. So let's make this blue. And what we need to do now is make sure that this is constrained somewhere. And this is, oops, not that. I need to pull this out. Always pull them out. And this constrained somewhere. And these two are going to get their motions from those joints underneath there, right? Remember those joints? So if I go to this one, you will see that the B joint 3 is this little tip here. And the B joint 3 is where this whole thing is going to be a child of. So now if I move this, you will see that at least the top now is moving. Undo. And let's do the same with the C joint over here. Which one is this? This is the A joint 3. Take this, make it a child of the A joint 3, because we want this controller to be right there where that A joint is. And look at this. It's doing the motion. Let's go and copy and paste stuff. Let's cut this and paste it here. Let's take this and cut it and paste it here. And now we have an extra step. And the exercise just finishes with the last of all constrained, which is going to be this one, and this one over here. So let's go and find these ones. So we have this one, which is the top. This one is the middle. And this one is the bottom. We're going to name these, you see, D joints. D joint and a space. And 1, 2, and 3. Let's go here, make them children. It's just a repetition of the same thing. Alt G, D root, and of course go set my IK, rigging, IK, third, add goal, pull it out. And let's find out what we need to attach to what. Now, although this is offset from this, it still is based on this double scissors rig. This is exactly this part here, the blue the red, the pink, and this is nothing more than a double scissors rig. So I need to take this D joint and put it as a child of this joint over here, the C joint. Let me make sure it is the C joint. Yeah, it's the C joint. So let's take this and put it here. And let's see what this does. There you go. It's moving it. Excellent. Now we need to take the bottom part, this one, the whole thing, and make it a child of this one over here. So this one is the C joint, if I'm not mistaken. Is it the C joint or is it the C1 joint? No, it's the C joint. Let's take this and make it a child of the C joint. See if I broke anything. No, I didn't break anything. Let's start pasting things. Cut, paste, cut, paste, undo, 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 cut. That was my shortcuts. I didn't get my shortcuts right. And there you have it. That's it. It's just you find the starting point, which is the most important thing, is to find the starting point. What is the simplest of all joints? Because there are ways to do this, rigging it in a reverse manner where you pull this and so forth. The only issue with that, I find, is that you need to be very careful with the priorities, because then you're going to have various things that work in a bidirectional manner. In this particular case, I can place this point wherever I want. I have the freedom to put it in all two dimensions, this way, that way, and everything seems to work. Whereas if you try and move this point will only move in the directions allowed by the evaluation of the whole system. So although you may find 10 different ways of rigging this, this seems to be the most stable and the one that requires the least amount of basic principles in order to put together. Okay?
Yeah.
So
this is very cool. You're getting a lot of really good comments on this.
thank you.
And yeah, this is it's something so simple that we're used to: parent-child relationships, joints,
Exactly.
polygonal geometry, nulls, and you're creating a very sophisticated, complex, behavior interaction between all of these things. And yeah,
Well,
it's very cool.
the funny thing is that you can take this mechanism or something which is 100 times more complex, goes on and on and on and on, and various things. It has to be plausible. It has to be something that works. By following what I
Mhm.
just did in the last 20 minutes and repeating it again and again and again and again, providing you started from the right position, all those mechanisms can be made without any problem. You just need to take it a step at a time, move
Mhm.
slowly, and define your initial post. Now, your initial starting point. Now, if this was the fixed point and everything else moved in relation to this, let's say this was a complex lighting rig where there was a light here or a camera here, and this
Oh,
was
this
screwed to the wall.
this is gonna
Well,
throw me off.
that you would have to start the opposite way. That's the whole thing. You get rid of all your joints and start the opposite way. Now, if for any reason you found a rig
Mhm.
like that and you wanted to disassemble it down to its measures, here's a quick tip for anti-rigging. Anti-rigging, right? We have all these joints, and all these joints have children and so forth. So you have to unparent them and all that. No. Select one joint, go to your funnel, double click on all the joints, and then go to Object and Delete Without Children. This is Delete Without Children. This will delete any of these selected elements without touching their children. And now you have only the geometry. You can delete all your nulls. So you can double click on the nulls and say Delete Without Children, Object, Delete Without Children. And here you have pure geometry, and you can start working again. So if you
Hmm.
ever get a file like this and you can't make heads or tails of what's going on, and you need to disassemble it, at least do it at the proper frame, because I started doing these things and it destroyed the rig. But in any case, maybe turning off the rigs would be a good idea. So find all the joints or all the IK tags, turn them off. So disable them, start with disabling them. And any other tags we have here? Nope. Then double click on the joints, then go to delete without children, then double click on the nulls and then delete without children and see if that is, oh, it's the rivets. right? The reason it broke is because I have all these hidden rivets here, which internally create nulls, so I can remove them and then do whatever I wanted to do. And here's your delete without children, and everything is in its place. And you can start rigging it again. But there are shortcuts in breaking down a rig if you want to do so. So this is the recliner. Now, sorry, there are many other things we can go. I have a little list on what I'd like to do first. Everyone loves robots, right? So this is the next one. Let's check and see if there are any questions. Have you seen any questions, Darren? And let's see.
There was a question, but you answered it before I even noticed.
Okay.
Yeah. Brian Smith does have a question. Can you have any slack in those joints, like a 2 millimeter rivet in a 4 millimeter hole, to prevent it from theoretically from seizing up?
Well, it doesn't matter because we're
Yeah.
working in 3D.
It's not a simulation. It's not.
Yes,
It's not a
exactly.
simulation. We're not running the risk of it actually seizing up because we're not actually, because the geometry isn't actually colliding. It's not a simulation. It's just
Exactly.
a rig. It's just joints.
And that's one of the reasons when Darren asked the question about if we can do connectors, if you were using connectors, because connectors work with dynamic objects, there's always you need to space them enough so that the simulation can actually work. But with these kind of rigs, what we have here is a totally, just fictitious thing. It looks real, but I can take this and put it here to overlap. I can take
Yeah.
this, I can break it, and it will still work
Exactly.
in the sense that still move it, and they will still work with their offset positions because it's all based on the pivot points and all that. So that's why this is a recommended, unless you're doing something that requires specifically simulation data, collisions, and all that. In most cases, nothing does. I haven't seen anything. I remember Transformers, that massive thing started maybe 10, 15 years ago, where they had those cars dancing, all those adverts that they did. Volkswagen did one, and then the movies and all that. None of that, they can add some simulation on top, but most of that is not simulated. It's all just
Yeah.
rigged, and things get smaller and bigger and all that. It's all fake. I have to tell you,
Like
everything
things
is
would just come from outside of the frame, from out of nowhere. But that was a really good question. Thank you, Brian.
Thank you.
Yeah.
Oh, Joey's here. Joey knows of my how competent rigger I am. Just tell everyone, Joey, tell everyone what a great rigger I am. So while you're doing that and posting compliments, Joe's a colleague of an extremely good friend. Go check out his work, Raw and Rendered. So let's see, what do we have here? The robot. Let's go to the robot because I find that very, very interesting. So, very competent. Thank you very much. I'm glad I didn't have to force you to say that. So we're going to see a few of the things here. So this seems like a simple rig, right? It seems like a simple rig. There's one little detail in this which makes it worth showing. And I just recreated it when I was doing my stuff. This has a bit more control than I'm going to show today. It's too bad that I can't share the models, and in some cases, I can't even show the models that I've been sent to troubleshoot because they're proprietary models, and clients can be protective of their IP as they should. And yeah, so let me go and find where's my Boltex start, right? This is the starting point. And in this exercise, we're going to talk about a few more things in the preparation of. Chris Pretty is here as well. Hey, 5'10 giant. He's grown.
Chris Pretty.
Yeah,
Is that 5'10 giant? Is
Yes, he's
that
another.
that my
Yeah,
is that my Hoosier brother?
yes, and he's another person that thinks I'm an extremely good rigger. We got compliments central today. So, okay, let's get on to business here, right? Um, so some parts of this are simple, right? This particular part of the model is going to move left and right. That's not a hard thing to do. You don't even need to rig it as long as you don't pull it this way and you break it. Okay. What we have here is the following peculiar thing. We have number one, some of these elements where the axes are somewhere which has nothing to do with the geometry. This is something that very often someone would receive from a client. And that's because various software deals with these axes differently and so forth. So we have, for most of these, I think the only one that has a proper rotation is the rotate geo, this one over here. This, for some reason, I don't know why, maybe I did it, rotates nicely on its axes because we can see that this robot here, this part of the robot, does rotate on its axis. If you want to make sure that you're looking at the right thing, go here, press S and rotate it. And if you see that the circles remain concentric, that means that you have a pretty good rotation. Now, it may not be perfect, but it's all fake in the industry, so who cares? As long as it looks, things are as perfect as they look perfect. That's it. If it looks perfect, it is perfect. Now, so we have this. What are we going to do about this, though? Look, the axis is here. Are you serious? And this, the axis is here. And what about this? The axis is there. So the axes are terrible. So how do we fix them? Well, actually, it's not that hard. It's simpler if these are in 90-degree angles. So let's go and find this. There we go. It is here. Now, if I go here, you will see that there appears to be some sort of geometric circle. Now, if there's absolutely nothing geometric that will give you a helping hand in identifying the center of your geometry to create your pivots, then you have to use the magnificent method of eyeballing. But in this case, we're quite fortunate because I'm going to create a null. I'm going to set the null to a circle. There you go. I'll make it 2. And then I'm going to get my move tool. I can't see it yet. I haven't touched it yet. And I'm going to turn on my snapping. I like to press P because I'm old school. Enable snapping, and we have point snap. Now, if I just click here, the axis is going to jump, and then I'm going to move it over here to snap right there in the circle, in the center of that point. Now, if I want to see and turn off the snapping and turn this off, if I want to see if it's actually in the center, all you have to do is just go and raise the radius a bit. And if you see that there's no identifiable offset, go here, put your cursor over there, use your down arrow to go at smaller increments, go use right arrow to go even slower. I mean, if it takes me too long to see if it's in the
Mhm.
center, it is in the center. So that's done. So we have that pivot. So let's make our circle bigger because I'd like to see where my controller is. And make sure that the circle is not camera facing, it's one of the axes I want. And you will use the axis where the rotation happens. It's very handy to have your various controllers. I'm not going to use this, but it informs me on the orientation of what I'm expecting to rotate, nothing else. Now, the next pivot point is up here. You know, if you look at this, you can see this is how this rotates, right? So I need to find this rotates at the center of this, I would guess. So let's go back to this view here. And let's go up here and see, there seems to be some nice little center there. Let's take, I'm going to call this bottom. I'm going to make a copy of this and call it middle. And P detach, enable snapping. Of course, you can click.
We do have a really good question from Sharon that I want to call out. She's asking, to rig a robot arm, do we have to zero out geometry to be straight up and down before we rig?
The answer is no. And the reason, not most of the time, no. In some cases, it will be beneficial. And here's the overall. excellent question. There is no upright position, any starting position. A robot's idle position may be already, let's say, maybe this robot's manufactured position is this. There's no rule that says that this robot, in order to work, we need to rig it with everything pointing upwards. It's like human characters. The contrary, we don't want the knees to be totally straight. But what we are
Mhm.
doing now, mechanical rigging, it doesn't usually make a difference unless there is an idle state which we want to revert to when we are done and we want to reset our coordinates. For example, if you have a car suspension or a car trunk, as I may be able to show today, uh, with a trunk closed, it's good to start from that, because when you reset everything back to its original, it will be closed. Whereas when it opens, you're not sure how much is the correct, let's say, opening. So although it's not technically necessary, sometimes it's good practice to identify what is the usual state, what is the neutral state of what you are making, and that neutral state will allow you to just revert all the values, because that's the state where your object is usually at. So the recliner, the contracted state would be the neutral state, not the one way the feet were extended. But that is just, it's not extremely important. So I created the copy, which is called middle. I'm going to go here. I've got my snapping on. And I'm going to, again, I like to do this because it's fancy. I just click and drag and it just pops here and I move it over here. Now I'm going to turn off my snapping and I'm going to make this smaller because we may have a bit of a discrepancy here. Let's do that. Let's, I can do is select this and hide it because I want to see this one. So middle, go here again, down arrow. Yeah, I think it's good enough. I'm good. I'm happy with that. I'm not even gonna talk about it too much. There you go. So we have the two points of our joint chain, because this goes from here to, let's say, here. Now there's an extra rotation on this, but that's a different thing. It has nothing to do with the usual joint chain as we imagine it, from here to here to here. So, but in any case, let's go and find this point just to create that little endpoint over there.
Hmm.
Now, there is, all right, I have an extension to Sharon's question, because while I'm presenting, I'm also thinking. In the case, when we talk about these rotations here, like how much this is rotated, it doesn't make a difference. But if you're talking, Sharon, about this rotation, then it does make a difference. And I'll explain why, in what cases it makes a difference, right? So let's take this and put it, what's this name of this? There you go. So if you start rigging it like this, one of the problems you're going to find is that you don't have an orthographic angle to find that center. You can always go set your lines, go shading lines, find that center and so forth. Oh, but the center could be on the backside. You can turn on. Anyway, perspective becomes a bit of a drag for that. Now, you either find the right angle, or there is a solution you can implement, and that is, you can go to the geometry you want and select a few polygons which show you the direction you want to face. And you can go to your, I always forget where they put them, these things here. Is it yeah, align work plane to Y. And that work plane to Y, where's my, oh, I aligned it here.
Did you want to line to selection?
No, the selection. I didn't do that. Thank you very much. Align,
Hmm.
align work plane to selection. This is going to set your orthographic cameras to this plane. Look at that. My grid now is aligned to that, which means that if I go to the appropriate view, the Y view, which is the top view, I would guess. Now, although this is rotated, right? It's rotated at an arbitrary angle. I'm getting that orthographic view and I can use it to place my nulls and my hierarchies. You do need, for these kind of setups, you do need your joints to be on the single plane because you don't have a gimbal joint here. These are just rotational joints. Here, here, these just rotate at a very specific angle. So let me undo a few times and go to that previous pre-rotation thing. Bring everything back over here. I need to make sure that I set this back to Y. This is the default as we know it. So thank you, Sharon, for asking the question because it gave me the opportunity to explain this. So we have that, and let's find this one now. Because there is a slight little pivot here, so what happens is that this pivots around itself, this little bugger here, whose axis is, it pivots to maintain a certain orientation. So I'm going to do the same thing. I'm going to go here. I'm going to find some, there you go. I have my little circles here. I'm going to call this bottom, middle, and end. I'm going to go and enable snapping. Move tool, click and drag. There is, I can test my circle again and all that. I'm not going to do that. I'm too lazy. Now, the next thing you need to remember is make sure that all these circles lie on the same X plane, right? They need to be 0. X is 0. This is 0, and this is 0. And that will guarantee that your rig is going to unfold properly. So let me quickly save this just in case. I'm going to call it DPP week 3. Enter. Just in case my power goes out and I don't want to build everything. Although if my power goes out, I won't be here to do anything. Anyhow, so let's create the joint chain. Now, I'm going to select these 3. I'm going to go to my character menu, and I'm going to press Shift and Join. And this will create one underneath each one of my nulls. And I'm going to drag them up. And we have the end, the middle, and the base. So let's set this to joint 1. This one is joint 3, and this is joint 2. Let's put them in the right order. Let's put our little root. And let's go and do our IK thingamadoodle. Right click and rigging IK, the third in the tag over here, add goal, pull the goal up. And what you will see here is now we have this 2-dimensional rig, which we're going to use. Another thing I like to do in these particular cases is go to the object, go to the display, set it to box, custom size, and just leave it. And this makes it look much, much better.
So in my head, I was like, okay, this is an interesting rig because there's essentially 2 points in the rig from which it can be manipulated.
Mm-hmm.
So I'm like, in my head, I'm like trying to sort of figure it out. But now I see how it's coming together, and it's more simple than I thought it would be. It's very cool. Sorry, go on.
Before it becomes more simple, it's going to become more complicated. And thank you for the second.
No, don't do that. Don't do that to me.
No. It's essential. It's essential because I'm going to show exactly what I was planning to show now. Because this rig now has a fundamental flaw. What is a fundamental flaw? Well, let's put this stuff where it needs to be. Let's take this and cut it and put it as a child of this. Let's take this and cut it and paste it as a child of this. Right? So what will happen now is if I take this and I move it on that axis, this works like a nice robot. I can take all the rest of this stuff, and I'm not going to remove it because it looks fancy. I'm going to remove it. I'm going to take these 2, cut them, and make them children of the goal. And now, when I take this and move it around on that axis, don't forget, everything works fantastically, right? This is the main motion. What the problem is now is that what if I move it on another axis? Because we know that the robot is going to pivot around if I want to bring this over here, right? Let's see what happens. Ooh, we broke the robot. Darren, what did you do? So first
I
of all,
didn't, dude, I'm just chilling.
right. The other rule I like to implement: go to the joint and freeze the transforms, so that then I can bring it back to its original position when I'm doing my rigging, just by resetting these or using
Mhm.
the reset transform. Okay. So here's where it breaks. Look at that. It broke.
Mm,
And this is
yeah,
a,
there it is.
this is a $500,000 robot, and I just broke it. But undo brought it to life. So here's the question, and this is, if anything, if you're going to take anything away from today's, uh, very, let's say, rich lesson, this is the one you need to take away. So I need everyone's attention here. This thing here, this rotation, is supposed to be the thing that rotates in order to facilitate the rest of the arm to go to the third dimension, this way and that way. Okay. So,
Do you use a constraint?
well, you're going to see what I'm going to use. So you need to
Oh my god, I
ask
can't wait.
yourselves, you need to ask yourselves, this rotation here, right? And the axis is in the right place, right? This rotation here, what does it need to be? How much does this need to rotate? Because obviously it rotates only on the H, right? You can see it here. So it rotates on the H. We know that. Where does it
I think
need,
I know what you're gonna
yeah, right? Where does it need to point at in order to facilitate this joint's lateral movement so that it doesn't break? Darren, where does it
do. Oh,
need
I
to
don't
point?
know. I don't know. I don't know, but I think I know what you're gonna use.
It needs
I
to
don't know what
rotate.
value, I don't know what value you want.
It needs to rotate where the joint goal is. If I move this here and this geometry rotates here and points in the right direction, providing, and here's the little trick, providing that the root is a child of that. All right. Because when this rotates, it needs to rotate the whole hierarchy to pivot it around. So if I take, I'm going to save this, I'm going to go here and I'm going to move it here. It breaks. But then I'm going to take the rotate geo and start rotating it. And you see it's now fixed again. So
Mm.
what we need to do is tell this geometry to point, currently its x-axis, in the general direction of where our controller is. And we could use a target tag, but that orients all axes. The way to orient only one axis is using the aim constraint.
Oh, Sharon got it. Sharon guessed it. Yep.
Yep.
Oh, and Hannah. Hannah
And
guessed it all. Good job.
you know
Good
why?
job.
You know why? Because they attend the shows and they do their homework and they pay attention, unlike you.
What? Oh, come on, man.
Did you watch the last 2 weeks? Yes or no?
No.
Exactly.
No.
Exactly. So,
Very
Sharon and
nice.
Hannah are coming on our show very soon. We haven't agreed anything. I just made that up, but we'd love you to be on the show. So let's go and get a constraint tag. Let's set it to aim, right? Oh, destruction. I've saved to make sure. And what I want to do is aim the X axis and only rotate the H as far as I remember. And I want to point it where this exists, right? This is what I did. I went beforehand. I saw what is that rotation we want. Then which axis do I want to point? The X axis. And let's see now if this is going to work, because I have no idea if it's going to work. And lo and behold, it works.
Mm-hmm.
Now, there is one little detail here, one more thing. And
Like
there's just one
butter.
more thing. If I do this and I undo and press A, you will see it did that. A does a force refresh. That means I have a priority problem. And the solution, let me explain why we have that priority problem right now. And that's because the aim is executing at the same time as the joint. Okay. I want to make sure that this aim executes at least a cycle before the joint, because first I want the whole thing to rotate to point here, and then I want the IK to resolve. Because if it didn't rotate, the IK would break. If it rotates, if it the IK is resolved after the rotation, then there won't be a problem. So make sure that this is a couple of even one priority steps before. And now I do this, I undo, I press A. Ooh, so that's not it. Maybe I need to do it after. I'm going to try this. Maybe there you go. Undo, press A. No, it has to be before. But I'm going to see what my issue is. It's -2. I'll put it at -2. This rotates after. So I'm getting a lag. Maybe I need to bring this down here. Let me try that again. Undo. A. I'm getting a little lag. I don't like that. Oh, it won't show when you're doing animation, but I'm afraid I'm forgetting something here because I had this, as you understand, very nicely prepared. So let me see if it happens on the one I don't.
While you're checking that out, I want to answer a question that someone asked, so that you do not have to illustrate it. It's a simple question. It's about a feature that we showed, the align to selection. The question, let's see, let me find it again so I can give credit where credit is due. Sandeep Kumar, he asked, does that align plane selection work with curved surfaces? The thing is, if you try to do it, the short answer is no. Long answer is, if you try to do it with a curved surface, what will happen is it will align to the average axis or
If you select,
average
if you select
normal.
one polygon, and it's not coplanar, you're going to have issues because it uses the normal. We're talking about the work plane alignment.
Yeah.
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 So it will aim at something. It will align with something. But if that thing is not flat,
Yeah, but yeah, I mean, the curved
it-
surface aims in every direction of its curve, so
yeah,
it doesn't know which point of the curve it should aim. So that's not really the idea
yeah.
behind the use of that feature. But that's a good question nonetheless. There's another question.
Yep.
What's the difference between the target tag and aim constraint? That
Um,
was
they,
from Frame
they do a
Step. Thank
similar
you, Frame
thing.
Step.
Yeah. It's not that you can't do with the aim what you can do with a target tag. It's just that the target tag is, let's say, limited. It doesn't allow you to constrain on certain rotations. It doesn't allow you to change your strength. It doesn't allow you
Mhm.
to add more than one targets. So there are quite a few different things you can do with the aim constraint. The target is simpler in its use. You can only add the target tag and what you're targeting and potentially an up vector, which I think it points the Y in that direction. But if you want more control, the aim constraint does that. And historically, the reason is that the target tag, I think, predates the
Oh
aim
yeah.
constraint. Yeah. So I can't find the reason for the. Yeah, I'm trying to find the reason for my delay over here, and I can't seem to find it, and I don't like that. Undo, press A. Yeah, and it does that fine little thing. I'm not going to delve too much into that for now,
Yeah, because
because
you'll find the answer like in a split second after we stop broadcasting, and then you can always
or
post it
yeah,
in the comments or
that's yeah,
whatever.
that could be the case. But in any case, as far as this works now or in an animation, there are absolutely no problems. There are absolutely no problems because we're instructing the rig first to point in that direction by rotating the parent, and then the rest of the rig still is on that plane. It's still in two dimensions. Now, for this particular one, I'm not going to go into the. I may go into partially the solution. The problem here is that you can see that this, because it's pointing in the same direction, and this whole thing rotates, you get this sort of rotational offset. Look at that. The way the robot takes care of that is it uses this thing, this big thing here, which I'm going to just center the axes to this. So I'm going to go UB, select, oh, I need to find a nice little loop selection, which I don't seem to have around here. Don't have a good loop selection here. Rats. I don't like that.
Select
As a
visible live
model,
selection.
let's see. It's going to be okay-ish, but
There
not
you go.
perfect. But I can take this and I can go, I've got the edges selected and I can go to tools, axes. I can center to, I'm going to go to the selected edges and I'm going to align my, let's say, Z axes to those selected ones. And this should give me this axis here for this object. This is sort of how you would sort of do that. And the only reason I did that because I want to rotate it. And you can see that this is detached from the orange. And the way the robot works is that as it moves laterally, it rotates like this to accommodate. And this, that's the funny thing. And this rotates with it. And this rotates the other way. So there are so many little differences, little tweaks. What I found in my early experiments, I'm just going to show this, is that if I rotate the, oh, I need to put it under a null because I want my, or freeze. Freezing is just like putting something under a null. So you can see the H rotation here. Look at the H rotation. If I rotate the H, the opposite way I'm rotating this. So if I take 59 and copy this and go to this and go here and do paste the opposite, I think I was getting a correct-ish rotation. It's not correct-ish. Anyway, there is a way to do this, whether you're rigging it or whether you're doing it in a more automatic way. But the only reason I showed this is that when you're doing complex rigs like this, there are many more considerations depending on how the machine was manufactured. There is a mathematical
Can I ask you a
relationship.
question?
Yes,
So that blue part at the end of the arm, what is that called? Is that that's a tilt
it's a
geo?
tilt gimbal. So
So
the way I think this is set up. Go ahead.
I was sorry for coughing. So what I and maybe I'm maybe this is me not paying good enough attention. But what I'm seeing is the problem with it not following the arm, because the arm looks like it's good. The pan geo looks like it's good. It looks like the rolled geo isn't going with it.
No,
Am
no.
I
What happens? Let me show it to you.
misreading? Yes,
I have
please.
it. I have it set up here. I don't
Thank
even remember
you.
exactly what I did. Let's just delete this. Now, watch how this works here. As this rotates around, goes here.
Mm.
Look how this tilts. It tilts left and right. So this is always parallel.
The
This
the
rotates.
pan geo.
Look at this value. I'm going to lock the attributes manager and I'm going to move this around. Look at
Uh-huh.
the value. It's
Yeah.
counter
Yeah. Yeah.
rotating.
Yeah. Yeah.
And I think the reason I did this here, and let me see the base geo. Look at the
It's
value
subtle,
here.
but I
And
see
let
it.
me
Yeah.
just delete this, go here. There, I think it's some relationship. I don't remember what I did. What did I do here? I range mapped it. It's supposed to be the same. I don't remember what I did, to be honest with you.
Okay.
I was just experimenting because it was slightly out of scope. Oh, and it's not even. Forget about this. Just look at the rest of the the
Yeah.
arm as it moves this way. It
Yeah.
sort of
It
rotates to
has that
counter
tilt. Yeah. Yeah.
the rotation. And all
Yeah.
these things, I mean, these things need a lot of thought. Sometimes the relationship is mathematical, right? For every amount of rotation of this, maybe the amount of rotation here is some mathematical relationship, the sine, cosine, or whatnot. I don't know. Um, you potentially could do these by rigging, but it requires a bit of thought to get these values correct. And that only applies if you just want your camera always to point forwards, right? Because if you want to add an extra control on top of that, then you need to add nulls if you want to pan your camera, rotate it, or spin it in different directions. All these things are, when you have the robot, happen pretty much automatically. Now, funny enough, robots, in order to retain these relationships, they use a lot of inverse kinematics math. So there's a lot of stuff going on. In any case, what I wanted to show
Wait,
in this,
that's an art. That's an IK arm.
yeah,
IK has a. Oh no, that's not it. Never mind. Never mind. Go on.
yeah. So just like we're moving this in a specific position, and the rotations of the motors rotate appropriately, that's how robots work. You tell it where to go, and it will create the IK and calculate the rotation of. So it has very similar software to our own IK sort of a system. What I wanted to show is that this combination of the aim and the joint is necessary to do a robot rig like this. And because everything is, properly linked now, I can take my whole robot and move it side to side at the same time, and it will still retain the relationship because everything has been set up. So as far as the pointing is set, it will work exactly as you want it to. So this is Robert. Let's see if we have a couple of questions here. And
there are a couple. Let's see.
Let's see. I need to go up. Oh, we usually star them so we can find them. So I'm back to the compliments. Thank you very much, Jerry. And let's start with, let me star a few. So let's see, Sharon again. To rig a robot arm, do we have zero out? Oh, you asked that and I answered it. Sorry.
We did hit that question.
Hello, studio. Very impressive. Thank you. Any plans realistic bird wing in the near future? It is an interesting one. We haven't. Send us an email on askthetrainer@maxon.net with a proposal, so we can put it in. I mean, it's a very interesting thing, which we can, even use some simulations for that. So,
and we don't have that in the character object, right?
No, well, I guess it's not just setting up the wings. It's rigging them, animating them so they seem that there's wind and all that kind of stuff. That's what I take from the question. Sharon, again, okay. So you're only setting up nulls and the joints before rigging? Yeah, you can do it directly with joints. It doesn't really make a difference. I just like to do that because I have that little circle. I can make it bigger. I can make it smaller. I can align it and all that. And joints are just glorified nulls. Let's not forget about that. So you can do it either way. It's just my habitual way of doing things. Let's go further down. Let's see. There has been target tag and constraint. Did that. Chris, if you have something to say, tell me in my face. So
yeah, you got something to say, man.
Chris, thank you very much for answering questions.
So, Noseman, I know that you in the past have done you've done a lot of tutorial content on Cineversity having to do with product visualization, yes. Including importing of assets. Do we have some videos on Cineversity to help Sandeep with importing CAD or SolidWorks?
There must be something. I haven't done anything, but I think we did some tutorials on CAD. Not on the new Cineversity. It's going to be on the previous Cineversity.
Okay, I'll do a quick search. You go ahead.
What I'd like to suggest to Sandeep is if you do have a CAD model that presents particular issues when you're importing it, hit me up on Twitter at NosemanGR and send me that or a subset of that file so I can take a look and see if that's particular with the export, because this leads to an interesting little rabbit hole. that a lot of the problems that there are some issues in, intrinsic problems between transferring a curved surface based model, a CAD model, into polygons, right? We are going to have those things. Usually, either the exporter, for example, Moi3D is a very nice little nimble one that creates this kind of topology. If you look at my screen, this is probably exported from Moi3D. It creates really nice n-gons and stuff like that. On the other hand, our importers, if you go here, you can see we can import all sorts of different importers. Go to your settings, import, export, and you will see the various imports here, CAD imports. And they're extremely, extremely good. It's based on a commercial library that does, quite a lot of conversions, but it doesn't do n-gons. It only works with triangles. So it could be the settings. If you are having a problem with your CAD models, there's a small chance always that there's an issue from the side of the export. Some setting was not good enough, or there's a better way to export it. But a lot of times the client tells you these are the CAD files. We can't re-export them. We got them from a factory. That's all. Then it's a case by case basis if you're having problems. To get better detail, to have fewer polygons and all that. But you have to start learning how to live with triangles. Now, Chris is very experienced with that. He works with CAD models a lot, 510 Giant. So you can start a conversation or something like that and talk about it. Or maybe we can get Chris on the show one day to talk about CAD stuff, right? Chris, let's talk. Call me. So yeah, that will be my answer. But Sandeep, just send me a file if you can. Of course, nothing leaves my desk, and if you tell me not to show it, I won't even show it. To test it and see where the problem is, and we'll take it from there. So let's see, what else do we have? FK Bone, yeah. Oh, Chris 510 Giant, Chris Pretty has a tutorial. I think it's on Cineversity or a presentation. Find it for us, Chris, and post it if you may. Thank you. So there don't seem to be any questions I missed here. Let me make sure.
Sadly, I have to go soon.
You can go. Well, let me see what else do I have, because I got totally. No, we don't, Hannah. Unfortunately, I have a license of Clo, but I haven't used it yet, so I wouldn't know. Darren, Clo?
Clo's an amazing piece of software, and I'm very excited to, in the future, being able to help you with your workflow there.
Excellent.
Yeah, sorry, I haven't learned it yet. I've certainly worked with some of our users that have and use that and still do use Clo, and then they just use Cinema 4D for their visualization. But so in those sessions, all I'm doing is really showing them, Cinema 4D stuff. I don't know the Clo stuff. Yeah, sorry.
So as you can see, I'm just going to do sort of an overview of how you would think about. Let me get rid of the tire and leave only the rim here. I think there's too much stuff going on here. In cases like this, it's no different than the recliner or anything else. You need to find what your fixed points are, for example, and how do you want to control this. So essentially what happens is, I guess, this here and this here and this here and this here and this here are parts of the chassis that are immovable. Okay. And the same applies to these screws over here. So you can take all these, bring them up, group them, middle click, go colorize them, and let's, automatic, let's make them red. So these are your fixed points. Now, we have various pivots. We have this that pivots on these fixed points up and down. And thank you, Chris Pretty, for providing me this model. This whole contraption here, 1, 2, and 3.
Kyle, put up Andreas's question, if you don't mind.
Oh, yes. How do you think it's been so handsome impacted your career?
I think the main question that we all have for Noseman is after all these years, how do you think being so damn handsome has impacted your career?
I don't know because we Greeks, as Andreas knows very well, are used to that since antiquity. So for me, it's just another Monday. Yeah. So
All right, sorry. Back to fixed points.
let's back to fixed points. So then, of course, you need to start grouping things together, finding out what are the parts that you need to put together. So I just cut them out. I'm going to paste them without selecting anything, so they're going to come up here. I put them under a null, make it invisible because now I know what I'm missing. I'm missing this. I'm missing this. Cut, select, paste. So now I know that that bracket over there, this bracket is one thing. Now I can always, again, make sure to weld it into one object. This is an essential part, or put it under a null. And now from this point onwards is a top wishbone. I actually went on Google to find out the names to seem smarter. Now, the next thing is to find the pivot point for this, right? And again, you will go to your typical find the geometry center. So maybe these fixed points are here. This is not. This is going to be an easy one because it's some sort of easy hexagonal shape. I'm going to do a loop selection of this, and again, this is going to be a little bit of a hack. What I'm going to do here, I'm going to go and let's say close polygon hole. Then I'm going to select this polygon, just select it, and I can do an inset, or I can do a little inset, then control click to select the points and go here and just zero these out. 0, 0, 0. There you go. That's my center. All right. I mean, for a model at this resolution, you don't need more than this. I'm going to show you another little trick. So let's say this is my center here. Okay. Let's get our null. Let's get our snapping. Let's enable snap and move my null right here. Now, the problem is I don't know if the orientation is correct, right? I don't know that. Now, by the way, I'm going to cut this and undo until before I made the hole and then paste my null again. You can do that, right? We can travel in time using Cinema 4D. So what I want to make sure is that this null, not only it's pointing here, it's not only it exists in this point, it's actually pointing in the correct direction, because otherwise we can end up with a broken hinge. Let's see if I pull this over. Oops, undo, get rid of snapping. I don't know if it's right in the center. That would only be the case if the geometry is aligned properly on my global axis, because when I generated this, it was generated 0, 0, 0. Now, if in any case you find that your object, your top wishbone, let me copy this. I want to show you, this is because this is quite important as a workflow, right? So let's assume that my wishbone was slightly rotated like that. And yet I wanted to find the axis that connects these two things, because I need to align something there. Well, in that particular case, I'm going to just select everything and connect objects and delete. I have fewer objects to fiddle around with. So again, you can choose your own way to do it. Let's go and do what I did previously. I'm going to close polygon hole here. I'm going to close polygon hole on the other side. And then I'm going to select these two polygons, this one and this one. And I don't know if the poke works in this particular case. Poke polygons. Yes, it does. So we're poking these, got our two centers. So let's just get a null now. Go to object mode, enable snapping, turn on these, move, click here. There you go. So now we know it's not oriented. How do I make this orient here? Well, it's as simple as cake. Make another null, drag it over here, and tell this guy to look at that one using a target tag. That's it. So now this is aligned. I can get rid of this, and I can get rid of this. If I put this under here, it's going to rotate correctly. There it is. Perfect rotation. No question about that. So geometry, when it's modeled properly, right? Because had someone modeled this off center, some of them would feel a bit broken. But if you are working with decent geometry where the modeler or you, when you're modeling, you were respecting the physical characteristics of what you were doing. You can use your geometry, the geometry, to inform you about various things like position, orientation, and so forth. And this um, target thing, I was tipped off for this technique from our new certified trainer in Australia, David Deloy. He came up with a technique to solve one of the certification questions, which was totally outside of the context of when we asked it. And it's fantastic that we can get this feedback. And now I'm using this regularly, where you just create two nulls, you make them, place them in the right position, make them point to each other, and suddenly you have an axis. You know, and this is very helpful. So let's go back to. I can close this. Don't need this. Let's see where we were. We're somewhere here. We were somewhere here. So you would use that particular technique to create your properly oriented null, which in this case, because the geometry is correct, that wouldn't be a problem. It appears to me that this would rotate fine like that. It's not fine, but I don't care. I mean, let's assume it's a car made, in Greece. So here's your one movable object. So you need then to start, asking yourselves how is this supposed to pivot? All right, if we can use this as our beginning, or we can use this as our beginning. These are the two parts of the model which are touching the chassis. These are the two. And funny enough, the pivot points for this are not in the center of this geometry. They're in the center of this geometry. So get this object. Let's find it. Make a null on this object. Take that null, cut, paste it at the top, and then take this, cut it, and put it as a child of this. Because I used the geometry that the modeler defined as the pin, and now I have this, which is rotating. So now I have two rotating apparatuses. Come on, Darren, help me here.
Apparati.
Apparati. We have the
Aperitif.
aperitif. Exactly. So let's get the aperitif here and paste it here, and let's make these the same color as that. And what I like to do is any color I make, you drag it here. When you're using your swatches, then select everything, just double click on your swatch, and you have all your colors here. So this is, let's say, the other, the rotating wishbone, bottom wishbone, right? And now it's up to you to define where you want to put the control, right? This is the typical, this would be here, your typical joint, one, two, three joints, and the clamp constraint to keep the distance. This was part of the parallel joint I made in week 1, where, just as a reminder, you do, don't want this, let's go and make some joints. Joint tool, press
Yeah,
control.
I wish you would have. I wish you would have started with the suspension. I think that was pretty cool.
Everything is interesting. That's what I would say. Everything is interesting. So let's do this and create a.
Well, that's because you
icon.
actually think everything is interesting.
But everything is interesting.
Yeah.
So here we have one part of my suspension, and this can be the wheel moving it. I just need to make sure that this is always at the same distance from, I don't know, the inner one. And again, go watch the other shows if you don't know what I'm talking about. You need to tell this guy to retain a distance from this. So go here, add a constraint, set it to clamp, tell it to clamp a distance on this. And now when I move this, there you go. That's your suspension. Top wishbone, bottom wishbone. You can invert it. You can put the constraint on the top and the joint on the bottom. But this will be the fundamental. Where are you? Why am I always losing it? There it is. And this will be the fundamental sort of trapezium shape you're going to have here. Joint, 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 constraint. Now, after this is done, because this locks your locks the setup. Go here, go right to the end. As you can see, once you've done this, your setup is locked. You can put your wheel here. So get your, here you go, cylinder, and point it towards the Z direction. Not Z direction, X direction. That's it. Here's your fat tire. And just put it here. And this should be the work. Wait, oops, it's not. It's the wrong joint. Undo, put it in the right joint. And there you go. Oh, it's not the right joint. I need to cut this and paste it here. It's the first joint. It's always the third one, right? When you can't make up your mind, it's always the third one. And there you go. Here's my tire going up and down. Everything else, and this is the funny thing, once you figure this one out, everything else is just a product of that. You just create a joint and you put the controller as a child of this object.
Or an amendment.
Sorry?
Right? Or an amendment.
Yeah, you can add, if this has other things that scissor or do whatever they do, you can use here.
Rotate.
You would use, I showed the first or the second week, I showed how to do the universal joint assembly. This is what you would do here to get the rotation of the wheel and at the same time have the axle broken. We showed that. And the last thing, what I'm going to show today is a way to deal with a spring. Okay, so let's go to this. Now, before we go to this, let me show you something here, something that seems like a bit of a problem. I'm going to copy this in a new document. And let me go and just zero everything so it's easier for us to deal with this. And I'm just going to go and fix my geometry a bit because it's easier to show what I want to show by fixing it ever so slightly. Nothing really much. And let's rotate it upwards. There we go. Now, this was a problem that Chris asked for, and I think the solution is not that bad. If I take this, I need a way to compress it. But if I use a deformer to compress it, the geometry is going to compress. I need, and the spring only compresses the actual distance between the gaps here. So I can't use an actual 3D model. I have to do something to a spline potentially. Now, the problem with the spline is that if you select that edge, it becomes smaller because it sort of loops inside. It starts outside, goes inside. So one thing I thought could work, and at the end it was quite interesting, was, right, I'm going to select all my polygons here. Oh, first of all, let me select the two caps. So I'm going to go and I'm going to go points, UL for loop selection. And I'm going to zero out all those points. Just so I have sort of like a closed shape. And let's do this here as well. There we go. The next thing I'm going to do is I'm going to select one of these edges, right? Here's my edge selection. I don't care which one it is. I'm just selecting one continuous edge. Then I'm going to go to polygon mode and I'm going to select all my polygons. The selection is not gone. All my polygons. Right click and say normal scale, 0. And again, until it becomes indistinguishable from a spline. Now this edge is somewhere in the average position of where the spring was. And let's test that. Go to mesh, edge to spline, throw away the old one and repaste the previous one. And what you will see here is, if I turn on my wireframe, not bad, huh? It's not perfect, but it's in there. And I think the only thing it requires at this particular moment is just to scale it on the two sides. And you're pretty much right there in the middle. Now, what I can do with this is use, and this is a trick where I found a minor little issue, but I think it's going to work quite well for rigging purposes. Get a null. I think people are going to love this. Get another null and call this, say, 1 top and 2 for the bottom. And I'm going to get a tracer. And I'm going to trace 1 and 2 and connect all objects. So this is giving me a line which works in this particular way. Now, one thing I want to warn you about, today I discovered there's a bit of, it has a bit of an issue, but I'll show you how to, if I have a point here, a controller, so controller, and I put this in here, and let's make this orange so you can actually see it. Let's make it green. Okay, we can see the green color. If I take this and move it and then press A, it goes back to the local position. But if you're animating this, there's no problem. So your animation is going to work, but while you're working with it, if it's a child of another object, it does something with the local position. I think it doesn't have a problem if this is a parent in the same position. Let me just try this. Press A. Yeah. If this null and this null are in exactly the same position, then you don't have a problem. If it's offset, it gets a bit confused. So in any case, I'll show you the method, and with that little workaround, you're going to be able to work around it because it plays with animation. And I've informed Maxon, and they're looking into it. So what I have now is a green line. I made it green, and the y-axis is green. So let me get rid of my axes. Is work plane and axes. Well, axes. There you go. That's cleaner now. The great thing about this setup is my tracer line grows larger and smaller depending on the position of these. And I can actually use these two when I rig them, when I put them on my suspension, right? I can make this a child of one part of my suspension, and this, I can put this on the chassis and put this at the bottom part of my suspension. What I'm going to do is take this spline and add a spline wrap. I'm going to take the spline wrap, make it a child of this, make sure it's pointing in the right direction because my line is going up and down. I need to make sure that this is sort of the plus or the minus y, one of the two. And I'm going to use this spline to drive that. If it reverted, just do that or something like that. Now, when I move these, I get a compressed spring. Now, if you use a sweep object to sweep this, you'll find that there is an oddity that happens here. And it's nobody's fault, really. Let's make this very small. What you're going to see here is that when I move, let's say the top or the bottom, my geometry sort of spins a bit. It creates, I'm going to reduce my segment so you can see this. What you will see is that the geometry, oh, it's working okay in this particular case. Oh, there you go. You can see it at the bottom. Look at the bottom of the spring and look at the geometry. It's sort of that. It's spinning around. Now, if you just have a basic metal shape, no one cares. But if you want this to be very stable, you would have to use a sort of a different method. It's slightly more complex, but I will end it on that. But I think it's worth doing. First of all, instead of a sweep, I'm going to go for a cylinder. My preferred method with spline wraps and sweeps and all that is to to deform cylinders. So I'm going to make this, let's say 2. I don't care about the height. We want more of these and 8 of these, just so I can see it. And make it 1. And what I'm going to do is use another spline wrap. I'm going to get a spline wrap. I'm going to put it on the cylinder. And I'm going to spline wrap it to this spline, right? And of course, I need to make sure that this is pointing in the right direction. If I make my cylinder plus Z, is it Z, X? There you go, X. It's always the third one. So what you will see here is that I'm still getting the same problem, right? At least now I know that, this is the equivalent of what we've done with the sweep. But what I can do now is say, okay, let me create something that will allow me to stabilize this by telling this spline wrap to have a rail. The ideal rail for this is another helix that has points a bit further out. And it still deforms. It's using exactly the same points. There you go. So both of my springs are springy. I will tell this to use my secondary one as a rail. And this stabilizes it. That's it. Because splines do not have inherent orientation. Anything that has to do with splines, deformers, and all that, you have to make sure that you provided a direction to point to. And now we have a totally perfect spring, which we can just take these two. Everything else can go under a null and call this spring. And by placing this somewhere and this somewhere else, you have your spring. That's it. You can move it. It will even assume the correct placement. So that is how you would complement this to rig these two things. In this particular case, you would put one of the nulls up here. Since I'm saying it, why don't I do it? Paste, get this null, put it, Shift S, put one null here, take the second one, put it down here. It's going to look a bit terrible, but I don't care. But in any case, there you go. And now when that moves, so Shift S to get rid of snapping, remember this, let's get that, it's the bottom. Let's take 2, put it where the bottom is, and let's just rotate this and see if it springs. Oh, didn't I use my 2 here? Oh yeah. There we go. I just need to make sure to, because remember when I said about the child, it's not working now because it's under that weird child. If I put another parent on top of it, that may work. Let me see if that's going to work. Nope, I need to press play. There you go. So that's how this particular suspension would work. It's just that nothing else is moving, right? I haven't attached anything else. But as far as the string is concerned, the spring, I call it string. The spring is concerned, this is how you would make it compress and so forth. Anyhow, we're an hour 38 minutes. And I think, let me see, maybe we can go just a few more minutes here. So let's quickly, I mean, the rotor head, kindly provided by a very kind user. He makes these models. It's fantastic. This, again, if you go to the second week and check out that Delta robot thing I did, that is how this would work. Just make sure you have the correct rotational axes over here, right? That's the axes you want. Just work with one at a time. Then what did I do? Did I get, yeah, the next thing is to find that top position null where this is, and basically just rig this exactly in the same way I rigged the Delta robot. Now, as far as the rotor head here, although the pivot is here, it would be a good practice to place that rotational pivot in the same sort of the same z-axis as this, right? It will work with this as well, but if you have this one aligned to that one in a straight line, and again, the way to do it is extremely simple. This is the root red. You can either move the root itself or shift and create a child, move this child wherever you want that to be, go to the top view, and you'll basically just align it with this little thing because you want it as close to that as possible. Now you make it a parent and you call it, let's say, red final. And then you apply the rest, which was basically a bunch of constraints. And you apply your null to this, which is the dynamic swash plate here, which you can then rotate in 2 axes. I'm not sure exactly how these rotor heads work, but this would be the case. It will, this pivot here can pivot either both ways, this way and this way. And this controls the pivoting of all the rotors. I think I have somewhere a quasi-final version. It's not 100% refined, but it's good enough. Let me just bring it up and close the show with that. And let's find rotor head rig. Let's see if this one is going to work. Yeah, congratulations. Open another Cinema 4D version. Well, 1 second. 1 second. All right, this is 2024.1. Get rid of it. Drag it in here. So is this the one I had rigged? This is not the one I had rigged. Just loading the textures. I'm just trying to find the rotor head that was working. Rats, where do I put these things? If I don't find it, we rotor head. Okay, last. I'm just looking on my folders. I'll be with you shortly. I think I know where it is. Let's go simplified. Okay, let me see if this is the one. Yeah, so this is a version before I implemented the other one. So this is a different version of that rig. And it's just the same rig 4 times. And it's rotating this based on the position of that. And I've used a bend deformer. I haven't finalized it to bend the plastic thing, but generally this is rotating. And you can see these are going up and down. And consequently, the rotors are going from flat to whatever angle they need for the helicopter to fly. I haven't rigged this up yet. These are just joint placements. And this is just that same joint placed there and tied to an object, which I'm rotating here. The dynamic swoosh plate, you go here and you define how much you want it to rotate. And again, you can see that it's having a bit of a problem and that's because I hadn't finalized this. This was one of my first experiments. Everything goes through a lot of iterations to be finalized. But yeah, this is nothing more than what we've seen in the last 3 weeks, just applied strategically in multiple places. So let's see if we have any other questions so we can close the show. I totally lose track of time. Let's see. Let me see a question. Yeah. Let's see. I think it was guitar arms. Anyone cares? Yep. Thanks for running. All the available source. Yeah, the models. Well, I don't know. Some of these are commercial. I can't give this. This is proprietary model. I can show it, but I can't share it. Only the ones I shared the first week. Those are the ones that are to be shared. Everything else, you have to see the appropriate creators and talk about them. Let me see. Is there anything else I'd like to show for now? I can close this. I can close this. I can close this. See, the collapsible cart, which I didn't get to, which is again just based on the same principles, and this is the outcome, right? Just 6 joints. And I'm using, if you check out my quick tips, the linear actuator joint. That's another method where you can cheat. And although it's rotational, it appears to be linear. So look at this going up and down. It's actually not going up and down. It's just rotating at a very, 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 very large radius. And we know that the larger the radius is, the more it becomes akin to a straight line. So it's using that. It's on the piston setup I showed on quick tips. And check out the quick tips. It's a maximum 4 minutes of extremely condensed information by yours truly. So let's get rid of that. We showed this wheel. I just want to make sure I didn't forget anything. We checked out this. Now, this is the trunk. And again, this is the same principle. These are the fixed points. Orange are the fixed points. These are the mobile points over here. And I can choose to create it any way I want. So in this particular case, the final one, which I'm going to open now. Again, thanks, Chris, for the model. Let me go quickly and find the fan wall so you can see it. And trunk final. Oh, I opened up Cinema 4D again. Trunk final. Octane, what's that? And there it is, just a mover, 1 point. And this has the exact same configuration. It's one joint from this static point to this mobile point to another mobile point, which attaches on the top. And you move this and everything else. This is the typical, the same as a suspension. It's amazing to see that essentially it's pretty much the same rigs again and again and again. And then you add some target tags, you add some aim constraints, you add some clamp constraints, and you can do so many things with this. And yeah, I think that's all I have for today. Oh, this is the thing that came up, and let me close this. This is 2021, 2024.1. Good. So let me bring up my face. There we go. Whew, that was a long one. Yeah, I hope you enjoyed it. I wish everyone Merry Christmas, Happy Hanukkah, happy any celebration you're into, happy holidays, Happy New Year above all. I hope that the next year is going to be the best one ever, and the one after that even better than that, and so forth. We hope to see you frequent our shows in the new year. And for anyone that's taking some time off, I hope you rest well, watch tutorials. It's the best way to take it easy. We have thousands of hours of tutorials and shows, so you won't run out of. You can get rid of all your TV subscriptions and streaming services and all that, and just watch Maxon Training Team tutorials. I mean, that's an idea, isn't it? Bye-bye, everyone. Thanks for watching. Happy New Year.
Lo, 'twas a winter-time eve out of a candy storybook. Twixt mint leaves and ginger trees, we awaited the cookie crook. Huzzah! The trap sprung, garlands pulled tight. With confection thief caught, I rushed toward the fight. Defeat and disaster upon the snow I'd been smote. And I saw on his parting gift an infuriating note. Apologies, tiny friends, I just love what you cook. Have a fruitcake in exchange. Till next year, the cookie crook.